Hi everybody, I'm going to do a video on the quotient rule and how we use it to solve derivatives. So, the quotient rule is used when you have a function where you have one function divided by another function and you wanted to find the derivative of that. So, the quotient rule says that you take the original bottom function, multiply it by the derivative of the top function, you subtract that by the original top function, and you multiply that by the derivative of the bottom function. That's all over the original bottom function squared. Now, one thing to note is that the order of multiplication for both of these terms, they don't matter. You can do f prime at x times g at x or the other way around. But the one thing that does matter is that you do the subtraction in this order. The g at x times f prime at x should be subtracted by f at x times g prime at x, and that's important. So keep it in this format and you won't have any problems. So let's do an example. Let's keep the equation there so we won't have any trouble. And as you can see, I label the derivatives in a different color to keep it more obvious. And so that's how we're going to do this first problem. This first problem, you see we have a top function divided by a bottom function, and when you have the division of two functions, then you use the quotient rule. So let's say I need to find the derivative of this entire thing. The way I'm going to do this is I'm going to do the derivative of the top and the bottom separately to keep it clear, and we can just plug it in. So I'm going to do it in this purple color, and the derivative of the top one is the derivative of x cubed is just 3x squared from the power rule, and then we have 5x, plus 5. And that's our derivative for the top one. Now we're going to do our bottom one. And we have 2x plus 3, and from the power rule, we know that we bring down the exponent, the 2 stays, and 2x just turns into 2. In case you don't know what the power rule is, just let's do, say for an example, we have x cubed. We're going to bring down the 3, the power 3 comes in front, and we're going to subtract 1 from the exponent. So x cubed turns into 3x squared. Now what we're going to do is we have our derivatives and we have our originals. So let's just plug it into this equation. So f prime at x is going to equal to the original bottom function, 2x plus 3, times the derivative of the top, which is right here, 3x squared plus 5, subtract this by the original top, x cubed plus 5x plus 2, and we're going to multiply that by the derivative of the bottom, and that's this one, so 2. We're going to divide this whole thing by the denominator squared. Okay, so here we're just going to simplify this out. I use a method called FOIL, the way I learned, just distributing the terms, and so we're going to do 2x times 3x squared, which is 6x cubed, and then 2x times 5 plus 10x. Then we have 3 times 3x squared, which is 9x squared, and 3 times 5 plus 15. Then we're going to move on to this one, and we're going to just distribute the 2 inside. Just one thing to remember that is very important and that you can forget very easily is that there is a negative, so don't forget to distribute that also in. So first we're going to get 2x cubed, then we're going to get 2 times 5x, but there's a negative, so don't forget to distribute it in. So you'd get negative 10x, and then you get 2 times 2 with the negative 4. All divided by the denominator squared. And now we're just going to simplify this numerator out, and here we can see that there's both 2 terms with x cubed, so we're going to subtract those out. we have 6x cubed minus 2x cubed gives us 4x cubed. There's only one x squared term, so we're going to put 9x squared, just keep it there. We have 10x minus 10x. Those cancel. And then we're left with 15 minus 4 plus 11. And I like to keep the denominator like this, just makes it a lot cleaner. And yeah, so this is the derivative for this entire function. And let's do one more example. This example involves the exponential function. So let's do it the same way we did the other one. And let's find the derivative of the top function first. And the top function is e to the x, and we know that the derivative of e to the x is e to the x. Now, the bottom function. And we know that this is a power rule case, x to the power of 5. So we're going to bring down the 5 times x to the power of 5 minus 1, which is 4. And then the derivative of e to the x is just e to the x, and we know that 5 is just a constant multiple, so 5 e to the x. Now that we have our derivatives here and our original functions here, we can just plug it into the formula. F prime at x is going to equal to the original bottom function, x to the power of 5 minus 5 e to the power of x. Multiply that by the top derivative, which is right here, e to the x. And then we're going to subtract that by the original top function, e to the x. Multiply that by the derivative of the bottom function, 5x to the power of 4 minus 5e to the x. We're going to divide that by the whole denominator squared. Once we have this, we can simplify this out. I'm not going to do it since I did the last one, but basically, similarly to the last one, you distribute this e to the x in like that, just like that one, and you would subtract any like terms that you'd see, and then you'd simplify it out to its solution. So, thanks for watching.